Thank you, guys. Thanks for joining this talk. First and foremost, I would like to thank OpenedX for accepting this talk. And what we are going to talk today is crunching the numbers of operating OpenedX platforms in Kubernetes. This presentation was created by Lawrence McDaniel and me. Unfortunately, Lawrence was unable to attend, and I'll be presenting for him. He sent you a special greeting, and I'll show you a short testimony he has about his experience running OpenedX installations in Kubernetes. So a little bit about me. I work for Edunext, an OpenedX provider since like 8 years ago, 5 years ago, working in the OpenedX world, starting as a developer and then moving to the infrastructure side of things. Now I'm pretty involved in the in creating the tooling necessary to run OpenedX in Kubernetes. Okay, so the agenda for today is we'll start looking at the basic Kubernetes stack for running OpenedX and a bit of historic context on how this effort is being developed. Then we're going to see some numbers about different providers running Kubernetes, running OpenedX in Kubernetes. Then we will watch the testimony from Lawrence McDaniel about his experience. Then we'll move to the ongoing efforts we're doing from Kubernetes Large Instances Working Group. And finally, I would like to show you some experience in our organization deploying and supporting OpenedX installations in Kubernetes. So let's start with the Kubernetes stack, but before talking about it, I would like to give you some historic context on how this idea of hosting OpenedX in Kubernetes was born. So everything started 4 years ago in the conference in 2019 when Regis Bemo, hi Regis, launched an incredible and powerful library called Tutor, which was, I will say, the first or one of the first efforts on running Kubernetes in a containerized environment. And from that point, different providers started to do different work, started to develop tools to streamline and to make easier to deploy an OpenedX instance in Kubernetes. And in the conference in 2022, there was an interesting meeting on Friday, the Friday of that conference, where different providers started to discuss what was the main pain points and to define a roadmap to start working on the best tools or a set of common tools to make easier the operation of the platform. So here what we have is a basic stack of Kubernetes. The diagram was built for AWS, but it can be applied for every cloud provider. So what we have in here is an elastic load balancer that receives all the traffic from the clients. And what we have is the elastic load balancer dispatches all the traffic to some nodes that are running inside a Kubernetes cluster that is created in AWS using a service called K8s, Elastic Kubernetes Service, and are spread across different availability zones to guarantee the high availability. And the databases are run outside the cluster. We can talk a bit later of about the convenience of running MySQL or running the databases inside or outside the cluster. But in here, we have the databases running outside the cluster. And we have, in the upper part, we have NAT gateways that allows communication of these machines in here to the internet. Why this is necessary? Because the machines in the Kubernetes clusters requires to download images to run the workloads of OpenedX. So these are some numbers of operation of different providers running OpenedX in Kubernetes. And these are pretty interesting. So the first one is related to the price. How much is running a small Kubernetes installation? The price can vary between $340 to $700. It will depend on different variations. If you are using the databases services that the cloud provider offers, or if you prefer using a self-hosted database. So those are some variations that generate this range. We are supporting more than 700,000 students with more than 2 million enrollment records and more than 30,000 courses. And those are part of more than 40 initiatives running in Kubernetes. And we had the opportunity to test this platform against a huge number of users in an exam with 20,000 users. So we know it works and it's battle tested. However, that's another story. Running a platform with a huge number of users can get really expensive. We can talk that more in detail in the next few slides. And I would like to show you, I was working on this presentation with Lawrence. Lawrence is a pretty active member of the community. He has done an interesting work with his tool that it's called Cookie Cutter, which allows you to deploy AWS OpenedX instances in Kubernetes. So let's play the video.
Hey, Johnny. Hello, everyone. Welcome to the conference. My name is Lawrence McDaniel. I'm a full-stack developer and a blogger in the OpenedX community. Okay, so lessons learned. Let's break these down into, let's say, pleasant surprises and less pleasant surprises. Generally speaking, it's been great. I have fully adopted Kubernetes. It's part of my infrastructure planning for all of my projects now, not necessarily the ones that run at scale, but any size. I'd say where there's 1,000 learners and up, which is almost every platform that I work on. It mostly plays well with Tutor and OpenedX software, so that's nice. I would say Kubernetes it's more resilient, it's definitely more scalable, it's more economical, and with a little bit of work and effort on your part, it can be made to be more secure. Not to criticize a native stack, but there's interesting new tools that are made available to you in the Kubernetes paradigm that are not available in native builds, and so that's interesting. It's increasingly easier to work with as you get up the learning curve. Okay, the less than pleasant surprises. It's a short list, but let me air them out for your benefit right now. Most importantly, for me, at the point in time when I got involved with Kubernetes, the transition from a native build kind of approach, or a tutor only, using tutor on, say, an EC2 instance to deploy the software, to transition from that strategy to a Kubernetes paradigm was not seamless. Another thing, this has since been overcome, but in my personal experience, getting multiple environments of OpenedX to coexist inside of a single Kubernetes cluster, which is pretty important requirement, I'd say, really for anyone who's seriously considering a transition to Kubernetes. That was a lot harder to do than I thought it was. It's done now, it works well, and there was a lot to that. I was focused on that particular problem for probably 3 or 4 months last year. And so suffice to say, there was a lot to it. Kubernetes is really only viable if you also are adopting CI/CD and you're adopting infrastructure as code. I'll try to keep this high level and light and quick, but just borrow my confidence on that statement. Kubernetes is a complex resource, and it is tightly integrated with the other resources inside of your cloud account. And if you didn't have the benefit of a tool like Terraform for managing that, I don't think that you could do that successfully, especially in a production environment. Those are my observations, pleasant and less pleasant. Now, on to the actual lessons learned. First and foremost, the way that I look at OpenedX projects has changed because of my adoption of Kubernetes and the associated tools that it depends on, like CI/CD tools and infrastructure as code tools like Terraform. For me, OpenedX platforms today are effectively the package software that's published by edX tcryl itself. It's the LMS, CMS, Discovery, et cetera, et cetera, et cetera. That package of software, a custom theme, a custom OpenedX plugin, and your configuration data to make that platform your platform. And that's it. And so the big difference is a couple of years ago, it was normal, or possibly even recommended, to fork edX platform, the repository, and then do customization things. If you do that, there are lots of negative consequences to systems management because you forked that code base. And by extension, I don't mean only edX platform, but really any software that edX tcryl publishes, they've over time evolved, and they provide tool sets today that give you the ability to achieve your goals, including customizations, without modifying their own source code. Today, when I'm approaching a new project, here's what I would say, is that edX tcryl, that tech team does a really commendable job of QC, QA testing of their code base. And what they publish, they have a lot of confidence in that software, and so do I. If you change that software, you're undermining those valuable processes that they're adding to the project. And so you want to avoid that. And so to avoid it, you want to concentrate the artisanal nature of your project to the theme, to the OpenedX plugin, and to your configuration, and that's it. Kubernetes as a concept, it benefits enormously from a community approach to solving problems. And that is happening today in real time with my colleague Johnny here, or there. Folks that might be in the room right this second. There's quite a few people, individuals and organizations that are part of the OpenedX community that are technical leaders in this topic. I want to point out specifically Edunext, not just Johnny here in the room. Johnny has colleagues, won't say anyone's names, but I work one-on-one with multiple technology professionals at Edunext and also at OpenCraft who are peers and or mentors of mine on the Kubernetes topic. And that group is collaborative, they're very accessible, there's a growing set of individuals inside of edX tcryl itself with that knowledge base. And that work group and others, hopefully in the future, are building the tools that this community needs to make Kubernetes easier to onboard, easier to manage, and in general terms, a better paradigm for managing your OpenedX platform. Because of the work that I began doing with Kubernetes, I now look at OpenedX projects in strict terms of configuration, build, and deploy as very discrete activities where certain things belong in one of those three categories and only in one of those three categories. And so that it's had a pretty significant effect, practically speaking, on how I'm approaching, the specifics of getting any OpenedX platform up and running and keeping it up and running. And lastly, the nature of my work has changed because of my transition to Kubernetes. Today, most of the work that I do today is spent inside of Terraform. The general pipeline for me is that my Terraform code is generated from the templating tools that are inside of cookie cutter OpenedX. And so that's a starting point. It produces a base of Terraform modules that I use for managing the VPC, the MySQL service, Mongo service, Kubernetes itself, the many things that I install into Kubernetes. All of that is taken care of with Terraform. And so I'm inside of Terraform probably 5 or 6 hours a day. And then the balance of my day is spent with, I guess what I would call the more traditional tools that I used to work with all the time. Python, React, a little bit of HTML, and so on and so forth. But those, I'd say because of the effort that I put into the infrastructure and the operating platform, and the fact that I no longer fork code from edX tcrl, has reaped some dividends. I'd say that, generally speaking, my work quotient, on a project by project is better. It's more efficient. And so I think I can safely say that I'm able to support more clients than I could before, and that trajectory is ongoing, that I think there's more efficiency to be realized on my part over the midterm because of the work that I do with Kubernetes and the associated tool set. Okay, that's it for me. The big show really is going to be Johnny. I'm very much looking forward to seeing the recorded version of this presentation. Johnny is definitely a mentor of mine. I'm very pleased to be in the room. It's quite an honor, frankly, for me to have been asked to participate as part of Edunext presentation to this work group. Edunext as an organization they're the technology leader on the topic of Kubernetes with OpenedX software. So definitely pay attention to what they have to say and take it to the bank. All right, enjoy the conference. Ciao.
Okay, so, summarizing what Lauren said at the beginning, it was sorry, yeah. Okay. Summarizing what Lauren said at the beginning, it was a pretty daunting effort, but thanks to the community efforts and the different providers involved in this work, this is getting easier and better. These are basically some of the advantages of using Kubernetes. Lawrence already talked about them. And before continuing, I would like to know how many of you have experience with Kubernetes? Okay, how many of you have experience running OpenedX platform in Kubernetes? Okay, great. Are you familiar with the tutor tool to deploy OpenedX installations? Okay, great. So let's continue. So what I want to show you now is the efforts we are leading in the large instance working group that was created last year. And basically those are related to how to, or what are the main pain points on running high scale instances. So we're going to check a couple of them. The first one is being a central load balancer with automatic SSL certificates. I'm going to going in detail when going to every slide, automatic scaling of both nodes and pods, some level of monitoring tools, shared resources to save cost. I'm going to talk to you about the Elasticsearch case that was a recent PR that was merged in a repository that is called the OpenedX Kubernetes Harmony. And yeah, the final one is publishing OpenedX Kubernetes Harmony Helm chart to be public and to be, so it's possible to fetch it remotely. Okay, so a central load balancer with automatic SSL certificates. With Tutor, if you use Tutor out of the box, you can deploy an OpenedX instance with no problem with this architecture. What you have here is a caddy pod, which is a web server that receives all the traffic from a load balancer, and then from the caddy pod, the traffic is dispatched for every service, LMS, EMS, and other services you run inside the installation. But you can have multiple of them. And if you are running these caddy pods in a cloud provider, for every pod, a new load balancer is going to be created. Which is a bit painful in terms of costs. If I have multiple installations here, so let's say 10, I'll need to create a load balancer for every installation to get them running properly. So what we did was implementing a global solution for all the installations in the cluster. So we changed a bit the architecture, and what we have right now is an Edunext controller, which is a service that will be in charge of routing all the traffic to the different installations according to the domain they're coming from. So here I have just a load balancer, and I'm getting all the traffic getting into the cluster here, and then this Edunext controller and an ingress object created in every namespace which maps to an installation, I can have my traffic routed properly. So the main advantage I have here, or we have here, is that I'm just using a load balancer for 5 or 10 or 20 installations instead of having one load balancer for every installation. There are downsides as well, because now I have to take in mind that this component is pretty important. And in some occasions, I'll need to scale it, because if I'm start getting too much load traffic from here, I'll need to have enough pods to respond to that high traffic demand. And the logging stuff starts to be a pain, because all the logging is concentrated here. So you'll need to start classifying the logs according to the domain it belongs to, so it's quite messy. But let's say for 2, 3 till 5 installations, it works pretty well. It works amazing with the Cert Manager, which is a tool that provides automatic SSL certificates. So it's an interesting synergy, and it's that what we are using as an official or as an accepted load balancing solution in the large scale instances working group. So the next problem we were facing was auto-scaling. Tutor out of the box runs with just one pod for every service, and that pod can grow or decrease in terms of consumption of resources, but it's just one. So we needed a method to scale the applications. For example, LMS. If I start having too many students, one pod is not going to be enough. I'll need to split the traffic in different LMS pods. So we have different mechanisms to auto-scaling in Kubernetes. First, we have the pod auto-scaling methods, which are HPA, BPA, and K8s. The HPA is it's based on the creation or on increasing or reducing the number of pods of an application based on the measurement of a metric. The BPA, vertical pod autoscaler, which allows to increase or decrease the amount of resources a specific workload can consume. So if a pod is consuming, let's say, 1 gig of memory and 1 CPU, BPA can measure historic consumption and dynamically change the amount of resources this pod can allocate to satisfy traffic needs in a better way. And K8s is just a special case on HPA, which is Kubernetes event-driven autoscaling, which allows the integration of HPA with different custom metrics. For example, Prometheus metrics related to, let's say, the number of requests I receive in a specific time window, or a similar metric. And node autoscaling, we have cluster autoscaler and Carpenter. Those consist on adding nodes to the cluster, and this cluster autoscaler is one of the most popular autoscaling solutions, and it just makes sure that every pod has enough resources to run in the cluster, so it will spin up machines in order to satisfy the loads of the cluster. Our Carpenter, which is a very flexible tool. Unfortunately, it works only in AWS, but does something similar than cluster autoscaler, but it's more flexible in terms of the type of machines I can add to the cluster, because it allows me to add to the cluster different types of machines according to my needs. The cluster autoscaler is more restrictive and just allow me to add one type of machine according to the configuration of my cluster. And what we have done so far is using HPA with any node autoscaling method. We don't have a preference between cluster autoscaler or Carpenter. Cluster autoscaler, which HPA for us has been shown interesting results, and it works pretty well. In most cases, LMS. I am going to talk about the two main services in the OpenedX stack. LMS and CMS workers are more CPU-intensive processes than memory-intensive. This information is gathered from different provider operations and metrics they've got during the last year. So our scaling is CPU-based, and additional to that, we have tuned the UWS SGI web server, which is the server that is running LMS and CMS, because it offers different options for tuning Fortunately, last week or in the last couple of weeks, a new PR was merged, and these settings are now easier to add to a tutor environment. So that's great. And these are the kind of CPU requests and limits we use for LMS, EMS, and the async workers. So basically, those numbers have been worked pretty well. Even with high traffic load testing, those values were used in a 20,000 students exam. Obviously, we had to get different ledgers bigger in terms of the databases and other stuff. But in terms of the workloads of the cluster, those values have worked very well, pretty well. In terms of monitoring tools, what we have is a stack that allows to install mainly 3 components, which are Prometheus, Alert Manager, and Grafana. So Prometheus as a data gatherer, Alert Manager as an alert dispatcher, and Grafana as a visualizer. This stack is basically a Helm chart, and this Helm chart has different configuration options, but by default, it offers plenty of dashboards that can give us an idea on how the cluster is behaving. With this stack, I can also monitor services that are external to the cluster. For example, if I'm running a self-hosted database, I can track it or monitor it easily. I just want to create a new object, which is a service monitor. And in this service monitor, I just need to configure the access for that external service or database. The service monitor starts to gather data, and the Prometheus stores that data that can be visualized through Grafana dashboards. Okay, we have, in monitoring, we have still challenges to solve. And one interesting thing to have is unified dashboards for OpenedX monitoring. I mean, a central panel with different dashboards and metrics that give you an idea on how your installation is behaving. And the other one is having Prometheus as a scale, which is, as I show you in a couple of slides before, I can have multiple installations in a cluster. So how I can start grouping those metrics according to the installation. So metrics per namespace, basically. In terms of shared resources, Tutor out of the box offers the possibility to run Elasticsearch as a pod, as a single pod. So if I have 5 installations, I will have 5 pods of Elasticsearch. But unfortunately, Elasticsearch is a resource that consumes a lot of hardware. So we decided to move to a shared Elasticsearch installation across all the cluster. So again, I can have multiple installations, namespace and namespace 1 and 2 are representing different installations. And what we have here is a global stateful set installation of Elasticsearch with guarantees high availability. Stateful sets in Kubernetes is a very special resource type that allows running workloads with this particular feature, which is high availability, especially with databases. to make sure that every write and read to the database is going to be performed in a correct way. So from our experience, okay, so I would like to talk to you about GitOps and large-scale deployment. So in the Ansible-based installation of the OpenedX, we had a set of tools to perform our deployments of our installations. And we didn't want to lose those features. And those features were a Git to manage deployments, an authentication system to access this GUI tool, and functionalities like rollback, resource pruning, logging, etc. So we started to do research about the topic, and we found this tool called Argo CD. And this Argo CD is a tool that is continuous delivery software that allows you to reconciliate the state of a Kubernetes cluster based on a Git repository. It follows the principle of GitOps, which basically stands that all the state of my, or all the resources of my applications are declaratively defined in a Git repository. And if I change something in the repository, it's reflected in the cluster. So it was taught for developers and operators. So when everyone applies a change in the repository, Argo CD will pull the change and then will apply the changes from the repository to an upstream cluster running an application. So I think I'm running out of time. So, okay, so. Okay, so I wanted to show you a small demo with Argo CD running, but summarizing here, we have the Argo CD graphic interface showing us a cluster. So here we have an application, which is a custom resource of Argo CD. An application is just a group of resources that I'm tracking in a Git repository. So here I have a visual of the nodes running my workloads, and here I have every workload running in the nodes, and I have here different options that allow me to like sync the application, which gathers or fetches the new changes in the repo, and apply those changes in the cluster. I can refresh my application to fetch the last changes, but don't apply anything. I can roll back to the last commit. So if anything goes wrong, I can roll back and go to the to a functional version of my application. So it's very useful. Okay, so Kubernetes in bare metal. We had the opportunity, indeed it was our first project. Kubernetes in bare metal poses different challenges, which are the load balancing layer, because I don't have a connection with a cloud provider here. Picking a tool to install a Kubernetes distribution, a control, since I don't have a cloud provider, I have to take care of the control plane at the etcd roles, and a storage controller. And our proposed solution was the following: using an external balancing layer that could be an HA proxy, but it's self-hosted. So you need to install it and configure it properly to connect to an ingress, which is running, which is a service running in node port mode. So from here, I'll have to route my traffic to the node ports opened by my service ingress, and from there I can jump to the different workloads. For the storage solution, we picked NFS. So again, there's an NFS server installed externally to the cluster, and with an NFS controller inside the cluster, we can connect to that NFS server, and we can start creating persistent volumes or persistent volume claims according to the needs of the application. Okay, so size recommended for an installation in bare metal. Minimum two control planes, two control plane nodes of size M6 large. Here, this is an AWS machine size, which corresponds to 2 cores and 8 gigas of memory. Minimum 3 etcd nodes, M6 large. This is to tolerate the failure of one of the nodes and provide you high availability. And minimum 3 nodes M6 large to run the workloads of the installation. So as I mentioned earlier, additional load balancer ledger which is installed outside the Kubernetes cluster, and an internal Kubernetes service running as a node port, and the NFS controller to connect to the NFS server outside the cluster. So for logging, there are plenty of solutions to gather logs in Kubernetes. There are 2 main groups of logs in Kubernetes, which are the logs from the control plane and etcd machines, and the other ones are the logs from the workloads. And we are right now using Vector, which has shown a pretty interesting performance. What we do is install Vector in the cluster as a daemon set, so it gathers the logs from every node, and it just dispatches them to a central vector aggregator service, which is in charge to send the logs to different destinations. Let's say S3, let's say CloudWatch, let's say a mini storage. So we are working with this model since trying to run the vector agent also as an aggregator or a direct dispatcher to the final destination showed a few complications. So we decided to extract the logic of the aggregation external to the cluster. This is not running inside the cluster, but outside. Okay, so let's review some common issues in operating in Kubernetes. Okay, so that's the last part. I can take a couple of minutes. So operating Kubernetes, too many errors, too many 502 errors. This could be related, or this can occur because plenty of reasons, but the most common ones are pod initialization. This means that you are sending traffic to your pods too early when they are not ready. And to solve that, you can use what it's called startup profs, which allows you to, like, for example, if the application offers a heartbeat endpoint, you can hit that endpoint unless you get a certain number of success calls to that endpoint, the pod is start receiving traffic. Pod graceful termination. Sometimes your pod is processing some request and it's killed brutally. So you can configure UWSGI to enforce a graceful termination. And conmaxH configuration, which is a configuration in Django that allows you to keep connections, MySQL connections alive and reuse them instead of creating a new connection when establishing or when performing a query. So we are now setting this value to 0 because a number different to 0 is causing constant disconnections from the database. Sometimes in your logs, you need to keep the clients, the IP of your clients to do some calculation, let's say geographic calculations. And this doesn't work out of the box. So you, if you have a load balancer in front of your installation, you have two options. You can enable proxy protocol. So the proxy protocol will forward the information about the client to the internal web server, or the usage of a level 7 reverse proxy, which can forward the header so you can get them in the applications. And finally, the async tasks are not completed, and this is caused again because the pod is brutally killed. So you can play a bit with a configuration which is called termination grace period seconds, which allows you to wait for a certain amount of time before killing a pod. This is a value that can be tuned according to the duration of your async tasks. So that's all for the presentation. This is the link of the repo we are working on, OpenedX Kubernetes Harmony. You are very welcome to contribute to this project. We have meetings every 2 weeks. So that's it. Thank you so much. It's unfortunate there's no space for questions.